Quantum Internet, the future of ultra-secure communication. The quantum internet is an emerging technological frontier that aims to revolutionize how we transmit information by harnessing the strange and powerful principles of quantum mechanics. Unlike the classical internet, which relies on the transmission of electrical signals or light pulses, the quantum internet uses quantum particles, typically photons, to encode, send, and receive data. This innovation promises unprecedented levels of security, computational power, and new communication capabilities that are impossible with traditional systems. How it works. The foundation of the quantum internet lies in two key principles of quantum physics. Quantum entanglement. This phenomenon occurs when two particles become so deeply linked that the state of one instantly influences the state of the other, no matter how far apart they are. This enables the creation of ultra-secure communication channels. Quantum superposition. A quantum bit or qubit can exist in multiple states simultaneously, unlike classical bits that are either 0 or 1. This allows for vastly more complex and powerful data processing and transmission. In a quantum internet, entangled qubits are distributed between nodes, users, or quantum computers. Information is encoded in the quantum states of photons and transmitted through quantum repeaters and quantum networks to ensure the entanglement is maintained over long distances. Key features and benefits. Unbreakable security. One of the most powerful features of the quantum internet is quantum key distribution, QKD. It allows users to share encryption keys in a way that cannot be intercepted or hacked without detection, as any attempt to eavesdrop disturbs the quantum state and reveals intrusion. Ultra-fast communication for quantum devices. The quantum internet will enable quantum computers to communicate and work together, creating powerful distributed quantum computing systems. Next-generation data privacy. The system naturally defends against many current and future threats, including those from quantum computers that could break classical encryption. Challenges in development. Despite its potential, building a quantum internet is incredibly complex due to photon loss over long distances, quantum decoherence, where quantum states are easily disrupted by environmental interference, the need for quantum repeaters and quantum memory to maintain entanglement. Researchers worldwide are working to overcome these challenges, with active quantum networks already in development in countries like China, the USA, the Netherlands, and Austria. Applications of the quantum internet. Government and military communications with the highest level of encryption, secure banking and financial transactions, advanced scientific research, including distributed quantum computing, healthcare and data privacy in sensitive industries.